Yeah.
Present, Miss.
Trishya. Trishya has not joined. Trishya. Jyotish. Karthik. Kavya. Kavya. Nachiket.
Miss.
Neeraj.
Present, Miss.
Okay. Neeraj. Neeraj on top. Ranveer.
Present, Miss.
Vaishnav. Vaishnav. Vaishnav is not there. Anjali. Shruti.
Present, Miss.
Present, Miss.
Miss Neeraj.
Neeraj on top.
And
Jyotish. Karthik.
Present, Miss.
Jyotish is there. Karthik. Vaishnav and Vaishnav. Okay. So last class, I have just corrected your series paper. You all can go through the marks and you can call me what was എന്താ നിങ്ങളുടെ എറർ എന്നുള്ളത് എങ്ങനെയാ മാർക്ക് കുറഞ്ഞ് കൂടിയത് എന്നൊക്കെയുള്ള സംശയങ്ങൾ you can call me and ask എങ്ങനെയാ മാർക്ക് ഇട്ടിരിക്കുന്നത് എന്നുള്ളതൊക്കെ അറിയാൻ വേണ്ടി you can just call me അതായത് ഇന്നൊരു 5 പേർക്ക് വിളിക്കാം tomorrow another 5 day after another 5 okay so today register number 1 to 5 you can just call me in the evening that is after 7 o'clock so you can correct you can see what mistakes you have made okay now last class we were just discussing about this IGMP protocol IGMP is nothing but Internet Group Management Protocol. Now I told Internet Group Management Protocol, it is the protocol that is used for multicasting. So multicasting in the sense one to many. You have a single source and you are transmitting the information to a group of hosts or a group of destination host. So that is called it as multicasting. Okay. So the IGMP protocol is mainly used for the multicasting communication. Now, for multicasting, if you want to perform multicast communication in the network, in the internet, what you require is you need some routers which are able to route multicast packets. So the routers must be able to route the multicast packet. Okay. So they are called it as local multicast routers. Those routers are specifically called it as the local multicast routers. Now, as seen from the diagram, consider you are having a multicast server and the server is sending multicast traffic to a group of hosts that is being connected in the network. Now, in order to do that, you are making use of two protocols here. In order to allow the multicast traffic to reach the corresponding host, two protocols are being made use of. One is the IGMP protocol. The other protocol is like PIN protocol that you are not studying. So just understand one protocol that allows the communication between the router host and the server is the IGMP protocol. Okay, so IGMP, what it enables is it enables communication between a router and a connected host. You can see it in the diagram. You are having a server, you are having routers, and you are having several clients of the destination host. So if you want to have a communication between the router and the connected host, the IGMP protocol helps to provide that. Okay, so understanding IGMP, what it does is it enables the communication between the router and the connected host. Now, you are having two important goals of this IGMP protocol. One is to inform a local multicast router that the host wants to receive multicast traffic for a specific group. The meaning is the server is sending the multicast traffic, and if the host wants to require that, they has to convey that information to the router. That is the first goal. That is the IGMP does that. So you are informing the local router that the host wants to receive the multicast traffic for a specific group. Okay. Now the second goal is you have to inform the local multicast routers that the host wants to leave a multicast group. Okay. So the routers, they will be sending some query messages to the host that whether they require the multicast traffic still. Okay, so these are the two important goals of this IGMP protocol. So IGMP, what it does is, so now what all routers are present in that network, they has to figure out where the server is and who is hosting that multicast application. Understanding the server, I mean the router, they have to locate where is the server and which server is hosting the multicast applications. Okay, now you have got 3 versions of this IGMP protocol. 3 versions of this IGMP, that is version 1, version 2, and version 3. Out of that, version 2 is considered as the default version. And when you are considering version 1, you can have 2 specific message structures. This is all last class I have told. This is just a recap. Okay, so this IGMP, it make use of the version 1, it make use of 2 specific message structures. One is the report messages, the other one is the query messages. So report messages means they are used by the client to join the group. So the host is communicating with the router with a report messages that they want to receive the traffic from the server. Okay, so that message is called it as the report message. Report messages, they are used by the client to join the group. Now the second type of message is called it as the query message. So query message is, it is used by the router to see if the members of the group still exist. See, once the router, it is providing the multicast traffic to a specific host, the router will be sending some query messages to inquire whether the host still require the traffic, still require the multicast traffic. So that is sent by a query messages. Very, very important. IGMP, 2 types of messages you are having. One is the report message that is used by the client or the host to communicate to the router, or they want to get the traffic from the server. They want to join the group. So that type of messages is called it as the report messages. The second type is called it as the query messages. And the query messages, they are used by the router to see if the members of the group still exist. The meaning is you are having a server who is hosting the multicast application. Now what the host requires, the host wants to join the group, or the host want to receive the traffic from the server. So what it will do is, it will send a report message to the router saying that, okay, I want to receive some traffic from the server. So that message is called through the report messages. Okay. Now this router, it will communicate with the server. That is with some other protocol. Okay. So the router, it communicates with the server with some protocol. Now once the router is sending the traffic to the host, what it will do is it make use of some query messages. So that query messages, it is asking the host whether they require any traffic still. Already it has been sent. Further, if they require any traffic, and that is being reported through the query messages. Understanding what is the difference between a report message and the query message. Okay, so Version 1 has got only these two type of message structures. One is the report message and the other one is the query message. But when you are considering the version 2, in addition to the report message and the query message, you have got another message called the leave message or the leave report message. You can see it in the last block. Now, what is this specialty is? See, I told in version 1, only two types of message, that is the query as well as the report messages. So report is the host wants to join the group. That is done with the report messages. Query messages, router is forwarding to the host. See, suppose once the router is sending the traffic to the particular group of hosts, maybe out of 4 hosts, 1 host has finished its traffic, does not want any traffic more. So that time, that particular host is not informing the router that, okay, it has finished, I don't want further traffic. It is not informing. There is no communication is happening between the host to the router. But what I told is the router is sending some query messages to all the hosts in a while. I mean, maybe 2 minutes or some seconds wise. So you don't have a communication between host and the router. So maybe some host, it does not want the traffic still. So the router will be simply sending the traffic to that particular host. Okay, so that is being, so there is some delay or some disadvantage in that. And that is overcome in the version 2 by adding another message called the leave message. Okay, so leave message means once if a host, if a host does not want any traffic more, it was getting, but after some time it has, it has finished getting that traffic. So that time it does not want any traffic more. So in that situation, they will send a leave report. Okay, so that is being present in the version 2. Right? So this is the difference in version 1 and 2 report, messages of the IGMP. Now, you have got the IGMP message format for that. So out of that, you have got different fields. The first field is the type field. This is where I stopped last class. So this is the type field. Type field means this defines, actually it is a 8-bit field. Now what it defines is, it defines the type of message. Now what is its value? That is based on the types of the messages. I have told you can have different types of messages. First one is the query message. You can have 2 types of query messages. You have a general query message or a special query message, right? And the other one is you have having a report messages, and the last one is the leave message. So if you are making use of a general or a special query message, the value of that particular field will be, it is denoted it as in binary. Okay, or you can just in hexadecimal notation or in binary notation. So you have, if it is a report message, you are having 1 value. If it is a leave message, you are having 1 value. So that value will be specified it in the type field. Okay, now the second field is the maximum response time. Maximum response time means it is a field that defines the amount of time in which the query must be answered. Maybe it will take a tenth of a seconds. So the meaning is, see, once I have told the router will be sending the query messages to all the hosts. So the host has to report. The host must be answered, right? So that is being specified it in the maximum response time. Now the third field is called it as the checksum field. As you know, it is carrying the checksum. Okay. Now the fourth field is the group address. So group address, if you are considering, if you are making use of a general query message, the value of that field will be 0. So 3 type: query message, report message, and leave message. So if it is a general query message, the value will be equal to 0. But other than that, other than if it is a special query, is it is a membership, a report message, or if it is a leave message, the multicast ID will be present in that group address. Okay, so these are the different fields of IGMP message format. So you have to just remember what is this IGMP and what are the different types of messages and what are the message format in IGMP. Okay, so I will just conclude it once more. IGMP is meant for multicasting purpose. So multicasting means one to many. You are having multicast the routers, you will be having a server, and you will be having many hosts connected to the router. So whenever the host wants to receive traffic from the server, it will join the group. And that process that is done with the IGMP protocol. Now, once it joins, the router informs the server that this host wants to receive the traffic. So the router will be sending the traffic, to the respective host. Okay, so and that is being, so once it has been sending the traffic, it will be sending some query messages also, whether the hosts are still required the traffic. So that is done with the query messages. And if a host is joining the group, that is done with the report messages. Other than that, you have got one more category of message, that is the leave message. And that is being present in the higher versions of this IGMP message types. And you have got a format for that with different fields: type field, maximum response time, checksum, group address, etc. Okay, understood what is this IGMP? Karthik is there?
Yes, miss.
Yes, understood what is IGMP.
Yes, yes.
Vaishnav is there? Vaishnav? Vaishnav is there?
Miss.
Okay.
Send it.
Okay. So the last class and this class, we were just, half of the class, we were just discussing about some protocols. We were dealing with what is IGMP, what is ICMP, what is DHCP, etc. So you just remember all these things. I don't know how many of you have read the textbook. How many of you have read the textbook? Please answer. Or Saturday was a holiday for you. See, until and unless you are not going with the daily portions, it will be very difficult. So this is almost to the end of the third module. Now 2 more topics are there. One is the connecting devices and the other one is the virtual LANs. So the third module, where I have started actually, the third module, it started with the logical addressing, right? Addressing schemes, classful and classless. And after that, you have just learned with the subnetting concepts. You have learned with the datagram format of IPv4 and IPv6. Then after that, you have studied some protocols. Address mapping, 2 types, ARP and RARP. After that, you have studied what is DHCP, what is ICMP, what is IGMP. Okay, now the next topic, what you are going to see is the networking devices, or first we will just see it as connecting devices. Connecting devices. Now, what is the meaning of that? I have told, when you are considering a LAN or when you are considering a segments of LAN. Now, how these LANs are connected is they are by means of connecting devices. They are by means of connecting devices. This connecting devices, they can operate in different layers of the internet model or the TCP/IP model. So what it means is the connecting devices, they can operate in different layers of the OSI model, the TCP/IP model. right? Now, generally, you can have 5 different categories based on the layer. So each layer I have got, what are the different layers in a TCP IP model? What are the different layers? They are having 7 layers, but it is clubbed it as 5, right? Now, what are the different layers in TCP IP model? Answer anyone? Yes? Jyotish, you can answer. Jyotish? Atulya? Atulya is there? So nobody is here. Okay, Atulya, answer. Which are the layers of the TCP IP model?
Layer,
7
7 layers.
layers is clubbed into 5 layers. You have 7 layers in OSI model, and that has been clubbed as 5 layers in TCP IP model. Now, what are the layers? The bottom layer is called it as the
Application layer.
bottom level. What is the meaning of bottom? Down. Below the bottom.
Physical layer.
Yeah, physical layer. After that,
Data link layer.
data link, then
Network layer.
network, then
Transport.
transport.
Session layer.
In TCP, all the 3 layers, so session, presentation, and application. Together, you can call it as the application layer. Okay, so you have connecting devices in all the layers of the TCP IP model. So I have told you can have different categories of that. Out of that, the one which operates below the physical layer, you have to just imagine the devices which operate below the physical layer. They are called as passive hubs. They are called as passive hubs. Okay, and the one which operate at the physical layer, they are called it as repeaters or active hub. So below the physical layer, you have the passive hub, and at the physical layer, you have the repeater, or you can call it as an active hub. Now, the one which operates both at the physical layer and the data link layer, you can call it as bridge, or you can call it as a 2-layer switch. Okay, and the one which operate at physical, data link, and network layer, you can call it as a routers, or you can also call it as the 3-layer switch. And the last one is the one which can operate at all the 5 layers. That is called it as gateway. Okay, so you can just see it in the diagram, how that layers are being.
Ma'am.
Yes. What?
സ്ക്രീന് കാണുന്നില്ലായിരുന്നു.
Screen is not visible.
Okay.
Now is it visible?
Oh, yes, yes.
No? Yes or no?
Yes.
No.
Few are telling yes and few are telling no.
എനിക്ക് കാണുന്നില്ല.
How come? Others?
കാണുന്നുണ്ട് മിസ്.
ഇപ്പൊ കാണുന്നുണ്ട്.
Under. Okay. Okay, so these are the layers. I mean, you can see it in the diagram. You can see, right?
Yes.
Yes, okay. So you are having all these 7 layers that has been, this is with respect to OSI model, it is being denoted. And the bottom layer, that is the physical layer, you have the connecting device repeater, and the one which connect physical and data link, you can call it as bridge or an active hub. Sorry, you can call it as a 2-layer switch. and the one which covers physical data link and network, you can call it as a router or a 3-layer switch, and the one which covers all the layers, that is called as the gateway. Okay, so this is how the layout will be. Now, the first we will be seeing about hub. Now you have studied, where you have studied about hub, that word hub. Who will be telling? Just recollect and tell me where we have used that. Huh?
Topology.
Topology. Yeah. In which topology you are making use of a hub?
Star.
So star topology, you are having a central controller that you are calling it as hub. The same thing, hub is nothing but it is a central controller which controls the traffic of the network. Okay, now you can have two types of hubs. One is the passive hub and the other one is the active hub. Two type of hubs, one is passive and the other one is active. Now what is a passive hub? So I told passive hubs are the one which operate below the physical layer. Okay, so passive hub is just a connector. You can just think of it as a connector. What it does is it connects the wires coming from different branches. It is just a connector. You are connecting. What it does is it will just connect the wires. You can call it as a hardware device. You are having some physical connections between the attached devices, and that is done with the help of a passive hub. Okay. Now the next one is called it as the active hub, or also you can call it as a repeater. Now that is also a hardware unit. Now what is the function of a repeater? It will regenerate the received bit pattern before sending them out. You can just see it in this diagram how it is being connected. You're having different LANs and you are making use of a hardware device called a repeater in order to connect these devices. These segments you can tell. Now, what is the function of a repeater? Now, I have told repeater what it does is it will regenerate the received bit pattern before sending them out. You can have two types of transmission is shown in the figure. One is right to left transmission and the other one is left to right transmission. So you have the corrected signal and you are regenerating it and you are getting the original, the regenerated signal out. Okay, so repeater is a hardware device which is operating in the physical layer. If it is installed in a link, what it does is it receives the signal before it is becoming too weak or corrupted. And what it will do is it will regenerate the original bit patterns and they will be putting the refreshed copy back on the link. Repeater is acting as a hardware device. What it does is before the signal is going weak or corrupted, what it does is it will regenerate the original bit pattern and you will have a refreshed copy out of that. Okay, so repeaters are also called as the active hub and they are operating on the physical layer. Right, so that is about the second type of connecting devices, passive and active. Together you can tell and club into one. Okay, now the next type of connecting devices is called as bridges. Bridge is also called as a two-layer switch. You can see how it is being connected. A bridge in the OSI model, it is being told, and TCP/IP it is also remaining the same. So as per the diagram, the bridges, it is operating at the two layers of the OSI model or the TCP model. You can just see it is in the physical layer and the data link layer. So bridges operate in both the physical and the data link layer. Now, what is the main idea of the bridge? That you can see it in the next figure. So what is done is you are having a bigger network what you will be doing is you will be dividing that bigger network into smaller networks or segments of networks or smaller sub-networks. So each sub-networks you can call it as segments. So the segments, if you want to connect these two segments, you will be making use of a bridge. Okay, now I have told it is including the data link layer also. So what it does is it is having the physical address of all the stations connected to it. Since bridge is operating at the data link layer, I have told your data link layer, your data unit is called it as a frame. If you want to identify each devices at that level or that layer, you require a physical address. Okay, so the bridges, it is having the access to the physical address of all the stations that is being connected to it. So once a frame enters a bridge, what it will do is, it is doing two functions. One is it is regenerating the signal, and also it will check the address and it will forward to the corresponding destination. Right? So you can see it in the diagram, whether it will be from A to D, you are transferring the data, or from A to G. Okay, so the bridges is having the physical address of all these stations connected together. So once a frame is entering the bridge, it will regenerate it, and also it will check where is the destination address. And once it's regenerating, you are getting a refreshed copy, and that copy and looking on the address, they will be forwarding it to the corresponding segment. Okay, now you can have three different types of bridges. One is called it as the simple bridge. That is what I have just told. You have got different segments and you will be making use of bridges to connect that. The least expensive type of bridge is the simple bridge. So if you want to connect two segments, two different physical networks, you will be making use of simple bridges. Now what it does is, or what it contains is, you are having the host addresses and some segment numbers in it. Okay, now these, whatever data I have told, you will be having a table, you will be having the host address, and you will be having some segment numbers. Now everything is entered manually by the administrator, okay, or the operator. So once the data entry is being filled, so whenever, if you want to add a new host, what it does is, it will be added to the table, or the table will be updated every time. Okay, but since it is done manually, errors can happen in it. Right? So that is the first type of bridges. One is the simple bridges. So simple bridges, you will be having a table where you have the host address and where you will have the segment numbers. Now each table, the table is being updated by the operator. So when a new host is added, or if an existing host is removed or deleted, now what you have to do is the table has to be updated every time. Since it is doing manually, you can have errors. Errors can happen in that. Right? That is about the simple bridge. Now the next one is the multi-port bridge, that you can see it in the diagram. More than 2 network segments, if you want to connect it. More than 2 segments of LAN, if you want to connect, you will be making use of multi-port bridge. Okay. Now the last type is the transparent bridge. So transparent bridge means everything, it does not have to be programmed manually. And what it does is, you can tell that automatically it does. So initially, when the transparent bridge is implemented, you don't be having anything in that table. The table remains empty. So once it receives a packet or a frame, you will have the source address, you will have the destination address, everything will be checked and decided where the packet should be delivered. Okay, so what it does is, it will be relaying the packet to all these stations that is connected to a particular segment. Okay, so the one which does not involve any manual help, you are doing that, that is called it as the transparent bridges. That is the second type of connecting devices. Hub, clubbing at active and passive, I'm making it as one, and the second one is the bridges. Hubs, out of that repeater, it is acting at the physical layer of the OSI model, and bridges, they are acting at the physical as well as the data link layer of the OSI. Right? Now, the third connecting device is nothing but the router. Router. Now, bridges, I told it is also called it as a two-layer switch. Now, the third one is the router. Router is also called it as a three-layer switch. Now, what is the function of the router? I told routers, it will operate on three different layers of the model. One is the physical, data link, and the network. So the router is routing the packet based on the logical addresses, host to host addressing. So you can see how the routers are connected in an internet network. You will be having different types of topologies. You will be making use of a ring LAN or a bus LAN, or you will be having many devices there, connecting devices. Now how the connection is going in, just imagine. So the router is a three-layer device which will route packet based on their logical addresses. Okay, so what the router has, you will be having a routing table. And the routing based on that table, you will be making the decisions about the route, where I have to transfer, which path I have to consider. The fourth module is dealing with fully of routing. Okay, that time we will be studying it in detail. Okay, just assume router, you will have a table called the routing table, and based on the values in the routing table, you will be making the decisions of which path you have to consider. Right? Now, the last connecting devices is called it as the gateway. Now, gateways, they are nothing but they are generally software installed in a router, within a router. It is operating in all the 7 layers of the OSI model, or the 5 layers of the TCP model. Now, what is the main thing is you are having 2 separate networks. Here, 2 separate networks. It is one is netware and the other one is the system network architecture is being shown. And if you want to connect 2 different networks, what you will do is you will make use of some gate. Okay, so it is a dedicated device which runs on a dedicated computers. Right? So these are the different types of connecting devices. So I have just told about the connecting devices. First one was hubs, second is bridges, third one is routers, and fourth one is gateways. Okay, so just understand how in which all layers all these connecting devices are activated. Hubs, usually physical and the data link layer. Sorry, hubs is in the physical layer. Now, bridges, they are in the physical and the data link. Now, routers, physical, data link, and network. Now, gateways in all the layers of the OSI model. Understood? What are the different types of connecting devices, and also we have seen what is the importance of IGMP. Okay, so one more class is needed to complete the third module that will be handling tomorrow. Tomorrow 1 hour will be handled by Indu Miss, and 1 hour myself will be handling. Okay, so I have forwarded the PPTs of module 3 last Saturday. I don't know how many of you have seen that. Anyway, just go through the PPTs and understand what is the concept. Okay, read the textbooks also clearly. Now, the first 5 members, you have to make me a call after 7 o'clock today. And before that, just go through your marks. Your assignments will be published tomorrow. And you will be having 1 week time to write that. And the very next day, you will have a unit test as per the schedule. Okay. Okay, I think the other staff has joined. Yeah, sir has joined. So, okay, thank you. We will meet tomorrow.